Today we're starting Unit 4, Polynomials, and the first learning target is learning target 15, how to classify polynomials. In order to classify polynomials, we must identify the degree and the number of terms. The degree gives you the first name of the polynomial. The number of terms gives you the second name of the polynomial. Feel free to stop this video and take notes as you are working. All of these notes should be in your notebook by the time we come back to school on Monday. So for the first name, degree of polynomials. If you have a degree of 0, that would be called a constant. Here's an example. A degree of 1 is called a linear. Here's an example. A polynomial with a degree of 2, we just tested on that, is a quadratic. A degree of 3 is a cubic. A degree of 4 is a quartic. Degree of 5 is quintic. A degree of 6 is 6th degree. Degree of 7 is 7th degree. And you can probably already guess as you continue on, everything 6th degree and higher is just the nth degree for the name of the polynomial. So 52 as the degree is a 52nd degree. And a degree of 100 would be the 100th degree polynomial. That's the first name. The second name when you're classifying a polynomial is by the number of terms. If you only have one term, this is called a monomial. Here's an example. If you have 2 terms, that's called a binomial. We worked a lot with binomials in the quadratics unit. Here's a binomial. 1, 2 terms. 3 terms is a trinomial. And then everything after 3 is just called a polynomial. Poly meaning more than 3. Polynomial for everything else. We have 4 examples that we're going to work towards classifying, and here's the first one. Example 1, classify f of x equals x to the 4th minus 4x plus 3x to the 4th plus 2x, and then identify the maximum amount of roots. In order to classify a polynomial in standard form, we need to first combine like terms if we can. And in this example, we can combine like terms. I have x to the 4th plus 3x to the 4th. That would be 4x's to the 4th power. And then I can combine the other 2 terms. Negative 4x plus 2x is minus 2x. So to classify this polynomial, first I look for the degree. In standard form, the degree of the polynomial is the highest exponent. So in this case, we have a degree of 4, which is a quartic. And then the second part of the classification would be the number of terms. And we have 2 terms for this polynomial, so that would be binomial. So my classification would be a quartic binomial. Then how many maximum amount of roots? Remember, roots are just solutions or x-intercepts or zeros. And if we're trying to figure out what the maximum amount of roots this could have, it's the same as the degree. So the maximum amount of roots, solutions, x-intercepts is 4 because this is a quartic, so it's the same as the degree. Example 2. Again, standard form. I have classify f of x equals x to the 4th plus 6x minus, so I'm going to have to do some operations first, 2x minus x to the 7th, and then identify the maximum amount of roots. So I'm going to combine like terms to have this be in standard form, just like in example 1. X to the 4th cannot combine with anything. 6x can combine with 2x, and I will subtract them. 6 minus 2 is 4, and that was the x term. So I used these, and now we have negative x to the 7th, but careful, make sure you distribute that negative. Negative times a negative is positive x to the 7th. I'm not in standard form yet, because in standard form I have to have the highest degree first, followed by the next highest, and then the next highest. So in standard form, I have x to the 7th. The next highest would be x to the 4th plus 4x. So now I'm in standard form, and I can classify by the highest exponent. So 7 doesn't have a special name. It's after 6, so this is just called 7th degree. And then I have 1, 2, 3 terms. So this would be a 7th degree trinomial. Which means that I have a maximum amount of 7 roots, or 7 solutions, or 7 x-intercepts when we graph a 7th degree. Max amount of roots is 7. So the first 2 examples were in standard form. Example 3 is in factored form. So we can convert this factored form to standard form if we want. And that would look like this. 2 times x minus 3 times x plus 1 squared. We have to expand that. Then I'll distribute the 2 to the first binomial. 2x minus 6. Write down the 2 binomials. And I will double distribute with the first 2 binomials, leaving the last binomial to do after. So I have 2x times x is 2x squared. 2x times 1 is 2x. Negative 6 times x is negative 6x, and negative 6 times 1 is negative 6. Multiplied by, eventually, this last binomial. I'm going to then combine like terms. So this becomes a trinomial. 2x minus 6x, negative 4x. Still multiplied by that binomial. And then we have to triple distribute. I have to distribute 2x squared to both terms, negative 4x to both terms, and negative 6 to both terms. So we have 2x cubed plus 2x squared, negative 4x squared minus 4x minus 6x minus 6. So now I'm in standard form, almost. I just have to combine like terms. 2x cubed minus 2x squared minus 10x minus 6. So to classify this polynomial, I would have to look at the highest exponent. That's my degree, which is a 3. That's cubic. And then I have 1, 2, 3, 4 terms, and anything after 3 terms is called a polynomial. So we have a cubic polynomial, and my maximum amount of roots, or solutions or x-intercepts when we graph is the same as the degree, so 3. Now, because this is in factored form, instead of converting to standard form, there is a quicker way to classify the polynomial, and that's by looking at the multiplicities. This is probably new for us. Multiplicities. The multiplicities are just the degree, or the exponent, of each factor. So we have a factor of x minus 3 and a factor of x plus 1. Both of those have their own multiplicity. 2, remember, is just the stretch. It does not affect your actual factors or your x-intercepts, roots, zeros. So we have x minus 3 has a degree of 1 because the exponent of this factor is 1. It's not written there, we know it's 1. X plus 1 has a degree of 2. To find the degree of the whole polynomial, then, we just add 1 plus 2. So you can add the multiplicities, the degree or exponent of each factor, to find the degree of the whole polynomial in factored form. So then we know that this is cubic, and we'll have multiple terms. So this is a cubic polynomial, which means the maximum amount of roots is 3 because it's cubic. Let's use this same trick with multiplicities for the last example. Example 4. Classify f of x equals x, there's one factor, times x minus 2 squared times x plus 6 squared. And then identify the maximum amount of roots. So we'll use our multiplicities of each factor. X has a multiplicity degree of 1. There is no exponent written for x, we know it's 1. X minus 2 has a multiplicity or a degree of 2. X plus 6 has a multiplicity or degree of 2. So the whole polynomial has a degree of 1 plus 2 plus 2, 5. Add up your multiplicities to get your degree of the whole polynomial. So a degree of 5 would be a quintic polynomial, which means the maximum amount of roots or solutions or x-intercepts when we're graphing is 5. If you have questions, feel free to talk about it with your classmates, send me a remind, or look it up on Google. Have a good one.